All right, thanks everyone, and welcome back again to my channel. Today we're gonna do the third part of this video series on Karaoke Machine design, and we're gonna do our very first test today. We're gonna do that with the Silent Night karaoke song. So we're gonna start with this, and then we'll go back into our usual tutorial and how to get to this point. So why don't we just play this song just for a few seconds to avoid copyright strike. We're just gonna play it for like 10 seconds and then we'll go back to the tutorial. Silent night, holy night, all is calm, all is bright, round yon virgin mother and child. We're gonna stop here. I don't know the copyright around Silent Night and all that Christmas Carol, but this, what you're hearing right now, is the complete design of the karaoke machine. We've done it. We did it. Right. So I'm gonna go into the tutorial, and then later I will show you the video um, of the test. Okay, gonna go back to the testing, right? But stay tuned. I'm gonna go back to my usual chalkboard. In this case, I don't use chalkboard. I use OneNote. So I'm gonna go to the OneNote and draw the circuit, show you what we did, and then we can actually. Why don't we just start with that? Let's view what we actually did. Let's see. Right. So right there on the screen, I'm gonna remove my videos. You've seen a lot, enough of me for today. Now, right there on your screen, you can see on one side the power supply and the power amplifier. I'm going to demonstrate later, so don't worry about it. And then you can see on the other corner, the little circuit there is our mixer, and then the other one is the tone circuit. So you've seen the tone circuit before, you've seen our preamp before, you've also seen the power amplifier last week, but today I'm going to look at it in a little bit more detail. All right. Okay, so let's go into that. Right, we're gonna make sure. I want to make sure the audio is streaming properly, um, because I want you to hear me properly. So for that, I'm gonna turn off the amplifier, because you can hear a little bit of humming from the background. This is sometimes ground loop. Sometimes it's just the amplifier. Sorry, the transformer. Um, the 50 hertz frequency of the transformer, 50 or 60 hertz, that are linked into the system. But I'm going to turn off the amplifier right now so we can go into our tutorial. Alright, the amplifier is off right now. Let's go and start our OneNote and turn off the camera. Um, I'm gonna make the OneNote a little bit bigger. Alright, let's get a full screen of the OneNote and let the tutorial begin. Just making a little bit adjustment. Okay. So we've looked at two blocks here already, how fast we've been. So we've looked at the tone circuit from the first day we started this series. We looked at the tone circuit, which is this one done. In the next video, part 2, we looked at the mixer, and today we're going to look at the power amplifier and the power circuit, the power supply. Alright, so let's get a new page for this. Power supply, we've looked at it before in a different video. I want you to please kindly look at our previous videos, watch our previous videos if you haven't done that. We're going to start with the transformer. This is an AC transformer, alternating current. We're using just um, 2-wire regular transformer. We're not using the center tap. Some transformers will have a center tap. That means there's going to be another connection from here, but we don't have that in this design. We're just using regular 2-wire transformer. And our power supply will have different options. So AC, so this goes to your wall socket, um, your wall plug, socket. That it goes from a plug to a socket, right? So on this side of it, so this is the secondary, and that side is the primary. Whenever dealing with an AC circuit, you have to be very, very careful, or extra careful, extra cautious, right? So on the primary side is 150, 110 volts or thereabout, and secondary side for this transformer is around 10.5. It's rated at 10.5. In some countries, the primary will be 220 or 240, and so let me just say that 110 or 120, and then in some countries this should be 220 or 240. The important thing for us here is to make sure that the output, the secondary, the rating of the secondary is compatible with what we want to design. Even if it's higher, it's okay. You can use voltage regulators. Also, very important, make sure that your primary suits the main supply in the country or region you're designing. I know many people are watching this from different parts of the world, so be very careful the transformer rating you're using. Now, on the secondary side, you want to connect it to a rectifier circuit. A simple one is this single phase or half wave rectifier. So these two will go into this. So if I call this A and B, then this will go to A and this will go to B. It doesn't matter the order actually because it's alternating. Where it becomes important is on this side. So this is the input and then the out. It becomes important in the out because this becomes positive and this becomes your 0 volts, right? So the input voltage then will be sinusoidal. Your output, so this is in, and your out will be, you're going to be losing the one half of the voltage. Then with the capacitor, the output will look this way. Alright, that's for half wave rectifier, so we call it half wave. You might get a little bit more ripples than necessary, so the voltage is going to look this way. For the full wave, which is what we use today, um, an easy way to draw a full wave rectifier is just to draw something like this. Draw 4 resistors all facing the same direction. Sorry, four diodes all facing the same direction. And this will go to your A, this will go to your B. Okay, where A and B is the primary terminals of the secondary terminals of your transformer. And then you need a filter here, filtering capacitor. Alright. So in this case, this is also positive, and this is your 0 volts. The waveform will be different though. Okay, let's make this shorter because we want to have room. So if this is your input, your out will look more like this. The full wave will make sure it recovers all your signals, right? Then with a capacitor, with a filter, with cap, your voltage will look something like this. So it's more, you get more direct voltage with a capacitor. This you're gonna get a lot of ripples, more ripples. Probably gonna contribute more to your. So this is also with cap, of course. For the half wave, you get more ripples. With the full wave, you get less ripples. More ripples, less ripples. In other words, it looks more like a battery than using half wave. So that's that for the power supply. You can pause this video at any point to um, get a circuit diagram. All right. Now, one thing I want you to observe here is that the voltage must be the voltage. Remember, this is positive. This is positive. So the voltage must be equivalent to what you require for your circuit. If it is more, then you need a voltage regulator. One of the voltage regulators you can use easily is one of these um, fixed voltage regulators. Let's say 7805, 7812. Okay, let's write two better. 7812. So it's just in, out, adjust. Same way here, in, out, adjust. Why they adjust? So you just to connect any of this, you just connect it the way it is shown here. So you're in voltage and out. Whatever the rating here, if this is 12, then you're gonna get 12 here for sure. Okay. All right. And probably gonna have some filtering capacitors and all that. One other key I want to show you about power supplies is that the filtering capacitors, the voltage of the filtering capacitors has to be 4 over 3 of the minimum 4 over 3 of the transformer voltage. So cap voltage, capacitor voltage has to be greater than or equal to, I'm going to redo this, greater than or equal to 4 over 3 of your transformer voltage. This is a rule of thumb. So let's say your transformer voltage is 10, then your so uh, V transformer V transformer is 10. If that's the case, then your V capacitor V cap has to be 10 multiplied by 10 over, sorry, 4 over 3. 4 over 3. Alright. So this will be 3.333, so times 4. So 3 that's you have to go with a standard rating, standard transformer rating, right? So if you do what we're saying here, so you're gonna get 10 times 3 times 4 will be like 12, and then 4 times 0.333 will give you a total of around 1.333. So let's say around 13 volts here, 13.33 volts. So the standard volts that you might see will be 16 volts. So you're gonna use 16 volts or more, 25 volts, 50 volts, it doesn't matter, but try not to get anything less than this value, 13.333 volts. That's for our transformer. We're done with the transformer. You can pause this and look at it again. So let's look at The other part, where is it? We're gonna look at the power amplifier, which is this box here. We're gonna look at the power amplifier. You can use anything for your power amplifier, any amplifier, any power amplifier as your power amplifier. So in our circuit, I will tell you what we used, right? But it doesn't really matter. You can just use any power amplifier. Um, but we use the TDA 2003. We use TDA 2003. It's a very, very simple amplifier. So I'm going to draw a quick circuit diagram for you here. Um, let's make it a little bit bigger. But again, I taught you the principle of block diagrams. Use block diagrams for your circuit. It's easy. When you use block diagrams, you can fill it with what you have. You don't have to buy something new. We use whatever we had for this circuit. This amplifier has about 5 pins. I think it has 5 pins. Yes, has 5 pins. So your power supply, your positive, is on this. So you can take 6 to 12 volts. All right. So remember, we're using 10.5 volts. So this is within the range we used this. So 6 to 10 will be fine. This is 6 to 12, sorry, this is your positive, right? And then the ground is pin 3. Pin 3 goes to ground. This is an easy design. Pin 4 is your output. So it goes through a capacitor to your speaker. So the speaker here, we're just gonna represent it in a classical way, standard speaker. And then your input comes from pin 1. It goes through a capacitor. Remember, we talked about capacitors: AC, short, DC, block, right? So you're going to send your input signal through pin 1, and pin 2, um, let's draw it out this way. So pin 2 goes through another, oh no, I gotta make it a little bit, give a little bit of, yeah. So this pin 2 goes through a capacitor, another capacitor, and the other side of it also goes through a resistor to ground. So I'm gonna draw yeah, this is ground. Okay. So you can also have like filters connected from here. So basically, this is what you have. This is all you need for this design, and that will be it. So okay. In some systems, when you look at the spec of this IC, in some of the spec, you would see a resistor connected this way, right? So this will be around 220 ohms, and this will be 2.2 ohm resistor. This capacitor here, 100 ohms, 100 microfarad, sorry, and this capacitor here, I'll use 10 to 47. We use 47 microfarads, and this one here we use 470. But in some circuits you can also get 1000 microfarads. Alright, so this is not very critical. TDA 2003. Okay, I'm not going to waste much time here, but you can use any amplifier. I'll give you some ideas. In the past, we've done with C1212. It's an IC based um, amplifier. You can use, I think I've used 810 before. You can also build other amplifiers. Maybe later in this channel we can put out more amplifiers. But the more important thing is that you have a power amplifier. And I'm gonna stop it here, and we'll go and do a little bit more testing. I'll show you the circuit diagram right there, the actual circuit, not the diagram, but the actual circuit. And if you have any questions, please put it in the comments, and we try to address them as we can. And next week we'll be doing the final video in this series, which is the packaging. So we're going to be starting off pre-work for the packaging this week, so that we'll be ready for next week video. All right. So again, I want to thank you for tuning in, and as always, remember to subscribe if you haven't done so already. All right. Okay, so let's go to the insert. Yeah, and then what? How about we get the we need the karaoke one more time so we can sing one more time. All right, gonna sing one more time. We're gonna sing. We're gonna sing. We're gonna sing. And then we'll go over there. I'm gonna turn this camera around. I'm gonna turn off my camera, turn it around, and we're gonna go sing one more time. But before that, how about we get the karaoke song on one more time? Where are you, karaoke? Silent night, holy night, shepherds quake at the sight. Alright, let's turn around. I'm gonna turn off my cameras, and then I will bring up the insert camera. So camera off and the insert camera on. Alright. Alright, so right here, I'm just gonna discharge my hands. Sometimes because of the cold weather, there's a lot of statics, so I have to discharge by touching a metal. Find any metal piece and just touch it to discharge any electrostatic charges on your hands. So do that. I use a bigger one, but I'll just show you what I would do is I'll touch a metal surface. So here is the power amplifier. On this side, this is the TD2003A right here. On the other side of it is the power circuit, or the rectifying circuit. Right here, you've seen this video, you're very familiar with this amplifier here. This is a LM386 amplifier. So alright, so we need to get the signal in. Alright, so there's a 386 amplifier we use as a mixer. Right there is our tone circuit. Right, the bars. I'm gonna make it a little bit bassy. You can hear the bars. And on the other side is the treble. You can hear the treble. The tone circuits working excellently well. Here's the volume control for the microphone I'm using. This microphone right here, that's the volume control. I can lower my volume and I can increase the volume. This is for the second channel. We have just one microphone today, so we're going to test with that. And that over there is the master volume. Don't worry about how they're sitting on this table. Next week we're going to have them in a package so that everything is together. So here you control the master volume. Right. Yeah. Alright. So I think that'll be it for us this week. And I will see you in the next one. Thank you. Thanks for tuning in. Thanks for joining. And please don't forget to subscribe. Very important, very important, very important, very important. Remember to subscribe, tell your friends, share this link, share this video, and if you have any video ideas, like I said, or tutorial ideas, just let us know, and we're gonna do our best to try to address it. And because yeah, I think this video is a little bit long as well, but it's all worth it, right? We appreciate your support, and we appreciate if you subscribe and inform others about our channel. Share the link with your friends. It's free. Subscription is free. Alright, just click subscribe if you haven't done so before. Alright, I will see you in the next one. Whoa. Alright, bye my friends. Please subscribe. Get us over the line. Get us over the line. Please subscribe. Share on your wall. Share with your friends. Alright. Yeah. So next week we're finishing the tutorial on Karaoke Machine. We have other part series that we started. We haven't finished. One of them is I believe it was a sorry, it was a walkie-talkie. Yeah, we started a walkie-talkie, so we haven't finished that series. We're gonna pick up on that series after. And we talked about coding channel. We created a channel already. It's Easy Coding. We created a new channel called Easy Coding. We'll be posting videos on that channel anytime soon. So we just want to finish this series so we don't get interrupted, but we're gonna start posting videos on that channel anytime soon. Alright, it's gonna be mostly software coding, so there won't be hardware building. So you'll be mostly probably live or probably recorded. I don't know, it depends on how things turn out, but it's gonna be coming out shortly. We're gonna build Android applications from start to finish. Some of our apps, like there was one app that we built. It's called Easy Switch. Yeah, we're gonna show how to build that Easy Switch and other apps that we've built and launched in Google Play Store. We're gonna show how to build some of those, but we're gonna start from scratch. Starting from downloading the studio and all that. Alright, thanks. Bye bye.